My name is Dalibert Topic. I work for Oracle in the Java Platform Group as a product manager, which is somewhat ironic because I don't have a product I manage. I spend most of my time working on open source stuff in the OpenJDK community. I tend to describe what I do as more like an open source janitor. So, I keep things working and so forth, but I don't necessarily write hotspot code or something like that. And I'm here to talk about what's new in JDK 13, to give you a sense of what's happening with JDK 14, and maybe some ideas of how to figure out what may be coming afterwards. And before I really get started with the talk, I'll give you a moment to enjoy the safe harbor statement slide while I enjoy a sip of Tainacher. It's good. And I'm sure you're all fast readers, so let's move on. Okay, so first, good news, everybody. JDK 13.01 is here. Last week, we released the first update of JDK 13. It doesn't have any new features because it's a critical patch update, and JDK 13 is going to get another one of those in January, and at that point, 13 is basically done. We move on to 14 as the next release. You can get JDK 13.01 in the usual places, from Oracle as Oracle JDK on the Oracle Technology Network, so java.oracle.com, under the OTN license, and if you like open source, and who doesn't, you can get it as the Oracle OpenJDK binary on jdkjava.net. This open source thing is somewhat new for us. We haven't been providing OpenJDK binaries when OpenJDK started out, but ever since we moved to this new, faster release cadence of 6 monthly releases 2 years ago, we've been delivering OpenJDK binaries straight from Oracle alongside the Oracle JDK binaries as well. And this new cadence has now been in effect for 2 years, so 4 actual releases, 10, 11, 12, now 13. And it's been a big change because all of a sudden Java releases come out in time. And that hasn't always been the case in the past, or so I know. But it's really changed quite radically now that we have, we plan for releases, we set GA dates, and we hit them, and it's very satisfying. Of course, this new cadence also means, as my previous speaker said, that if you're on this rapid release cadence of, say, adopting 12, then you have to move to 13 when 13 comes out. And then to 14 when 14 comes out, and so forth. That's why in this cadence there is a space every 3 years to have a long-term support release, and we have chosen 11 as the one from last year as a long-term support release, and then 17 will be the next one, and support for 8, of course, continues as well, so that those organizations and users who prefer to have production environments they can rely on for a long time and to migrate between releases at their own volition and their own pace can also do so, while everybody else who prefers to get features as soon as they are ready to be used in production can do so as well. And this way, this cadence supports different migration paths. There is something in it for everybody. Oracle also offers commercial support, so do others, so let's focus on what's actually in there. And like I said, the interesting aspect for me of this cadence is that it's become predictable. The JDK releases now take about 9 months from inception. 13 was started in December last year until September this year. They just spend about 6 months fixing bugs, adding new features, and then 3 months in rampdown, where the issues getting fixed are progressively pared down from P3 to P1, P2 to P1, P1 showstoppers only, and then you go and release. And nicely enough, this process also leads to release candidates that end up require maybe 1 or 2, at most 3, and then you're done. So it becomes rather easy to hit the GA dates while maintaining high quality. And 13 has 5 big features, as we call that we call JEPs in the JDK planning process. I'll go into each one of those in the presentation, but what I wanted to first show you is this radical difference in perception in terms of how many features are in the releases. In the old days of long developed, long gestated releases, it would take 2-3 years or longer. You would end up having 60 or 80 features, and then you would then have to evaluate if some of those features may actually defect in some not so positive way. Whereas with this new release cadence within 6 months, there isn't that much time to pack it with 60 things, 60 big things. So accordingly, the number of JEPs that makes into each release has shrunk down to around 10 on average. And JDK 14, for example, now has 3 JEPs targeted for it after a month after the GA of 13. And still has 2 months to go before it's ramped down. So that also comes at around 10, which means that from one release to the next, the amount of change is much lower, and therefore the risk of migration is also much lower as well. And as in previous talk, you could see that the amount of things that are really potentially affecting compatibility from release to release is very tiny under this cadence. But of course, if you choose to go from 8 to 11, that's fine too. If you go from 11 to 17, that's fine as well. You still have about the same amount of features that go into those big LTS releases. They're just dispersed across a more regular, predictive amount of time so that you can actually adopt them as you go. And JDK 13 is a community effort. We're not doing this alone. Although Oracle does a huge chunk of work on this, other organizations such as Red Hat and IBM, Google, SAP, smaller ones like Bellsoft and Azul, Amazon are all contributing various bits and pieces to JDK development and continue to do so. And that's part of why I think OpenJDK has evolved to become this really interesting community where a number of different participants come together to move Java forward and build JDKs together. So what have we done for you this time around with 13? Well, we have done something very similar to what we've done for you 6 months ago in JDK 12, where we had switch expressions as a preview feature. And switch expressions basically extend switch statements so that you can use them either as statements or as expressions. And they have traditional, good old way of doing things, and a simplified scoping control flow, which I'll show in a minute. And in 13, there is a small change. There is a new statement that allows the switch expression to return a value, to yield a value, which has been based on feedback that we received during the lifetime of 12. And the goal behind this feature is to simplify everyday coding. Now, I hope for most of you that you don't find yourselves everyday coding switch expressions all day long, but if you do, this will change your life radically, right? So, and the real idea under the hood is to prepare other features that will build on this, like pattern matching in future. So, the first change is that with this JEP, we eliminate the fall through from switch statements. So the simplified form does the right thing, doesn't require to type break after each statement. And aside from being, that way requiring fewer lines of code, it's also clearer. Because if you're teaching Java to new developers, one of the things that's really hard to get is that different things will happen depending whether there's a break in there or not. In the simplified form, there are no breaks. It just does that thing and that's it. So that's simpler and removes the source of errors, which is good. But it also lets us use switch statements as expressions themselves. So when you have something that's like a function, where you have some code that does something based on whatever cases you have, and then tries to update a variable on a result, you can move to code that basically treats the whole switch as a function in itself and evaluates the results of it. And expanding on that further, sometimes the way you do this is a bit more complex. So this yield statement can then provide different results, for example, in different branches, and make it clear that you're returning something that users assign. So this doesn't look very complicated. It should be relatively easy to use, but there is one catch. It's a preview feature. And preview features are a mechanism that was introduced in, I think, JDK 11, which allows us to provide language features that are fully implemented. So the compiler does all the good stuff for this. The VM understands it. They're fully specified, so the Java language specification has a whole section how the feature works. But the feature is for preview, so it's not permanent. It can change from release to release. And therefore, the purpose is to get real-world feedback from developers like yourself, whether this feature actually makes their day-to-day switch statement writing better or not, in order to refine it is necessary, or maybe decide, well, this is not quite what people need and want, let's do something else. So that means to try it out, you have to both enable it compile time. It's a language feature, so the compiler has to know, yes, you want to use this preview feature using the enable preview flag in Java-C. And you also have to tell at runtime to the VM that it's supposed to run with preview features enabled. And so those are release specific. So you can't, the preview features for 13 is for 13. And so you can't expect the JDK 14 VM to run your 13 preview features because they're supposed to be impermanent. They're just there for that release, in this case 13, 13.1, 13.2, for the purpose of receiving feedback. Once they are permanent, then of course they're always available. But until then, you have to play with the switches to try this stuff out. The other language preview feature in 13 is something called text blocks. And there was a previous attempt to have something similar that didn't reach the stage to become a preview feature called raw string literals. And the basic idea is that not everybody just writes Java. They sometimes intermix your Java code with code written in other languages. That may be HTML, it may be SQL, it may be something else entirely. And it's often the case that you end up having to have multiple lines of text somewhere in your Java code, but you then have to, concatenate and then manage that. Looks weird, it requires it to do interesting things to it. So in 13, this text blocks feature allows us to have multi-line string literals so that you don't have to clutter your Java code with escape sequences, you don't have to deal with string coordination, and instead it becomes easy to express such strings that span multiple lines of code verbatim within Java code itself. And that's a lot of words to show you something like this. So let's say we have a string that gets a bit of HTML code. Before 13, you would basically end up concatenating stuff and hopefully aligning it right in your IDE, adding extra spaces so that it will all look good. With the text blocks feature, you can use this triple, whatever that's called in English, I don't know, to tell it that it's actually, next block is basically text block. And then the compiler will take care of, turning that into string. And it will also take care of indentation. So in this case, it'll know to drop the first, 10 empty spaces because they are not relevant to this coding question. And that means that what you end up having in your code base becomes much more readable. HTML, it's readable, it's okay, fine. But JavaScript, of course, everybody finds JavaScript very hard to read, right? In particular, when you have it in your Java code with all these escapes of Java string escapes, then you have something that's much simpler and pleasant on the eye. Again here, because it's a preview feature, you have to enable this both at compile time and at runtime. And again, here we're asking for feedback, whether the feature in this form makes your life easier, whether it's acceptable, and let us know so that we can then, if it's find this form, enable it in future release, or maybe modify it and change it. That being said, each JDK release, even on this short sequence, doesn't just have language stuff in it. It has typically changes across the board. So there is also things that change in the core class libraries. There are things that change in the VM itself. And 13 is no exception. And one thing that's changing in the core class library in 13 is that we have modernized implementation of sockets, which used to be, well, pretty much the same design that was in place for the past 20 years. And in the past 20 years, a bunch of things happened with Java. We had NIO and things like that. And so in 13, the actual implementation you get when you work with sockets is based on this on new I/O. And that in turn lets us both make life easier preparing for the future for things like Loom and fibers, but it also lets us have something that's going forward going to be much more maintainable, since it eliminates the need to drag along a whole bunch of native code, C code, and has various other improvements under the hood. The actual behavior is mostly unchanged. There's a few weird edge cases, so that's why there is a flag you can use, a property you can use to turn back the old implementation on and use that instead. But we expect that a future release will simply remove the old implementation and the property to go along with it. Yeah, that's all that's really to say about it. And then on the VM side, we have something called Uncommit Unused Memory for ZGC. ZGC is a garbage collector, and ever since we introduced a garbage collector interface in JDK 10, I think, there has been a Cambrian explosion of garbage collectors in hotspots. So we have since acquired Do Nothing garbage collector, collect Epsilon, Shenandoah, ZGC. So there is a lot of work happening in this space across the board. And ZGC is an experimental GC from Oracle that's focused on huge heaps that works basically by focusing on really low latency. And one of the interesting things is when you run your garbage collector in the cloud, you pay for things like memory. And so some applications have a profile where they initially end up doing a lot of stuff. So they slurping gigabytes of, say, data. And then they extract something from this data that they work on. But the initial objects are returned, and the memory just stays there in the VM, committed by the OS. And so in G1, we introduced a feature intent to give memory back to the operating system. And ZGC now has the same feature, so that it will return unused memory, where it determines, okay, this is safe to give back to the OS. We don't really need this in the state of the application. Back to the operating system, reducing your overall memory pressure. This is on by default, and of course, if you like to have unused memory in the VM, that's fine too. There is an option for that, Uncommit, that you can use. And you can set delay until memory is being returned. Another aspect that we strive to improve with each JDK release is startup performance, because that again is something that people are really care about in environments that where they pay for processors and memory. How long it takes for the VM to go from I run the command to it actually runs the code I care about, rather than VM code itself. And there's been a number of features that have been added over the years to the hotspot VM to make this go faster. One of them has been class data sharing. That's been around for, I think, 15 years now. And it's been on by default since JDK 12. What that does is it computes a more efficient representation of class libraries that can be more easily and rapidly mapped into memory, so that a lot of the initial startup gets basically blown away by that. And we've expanded this feature in 11 and 12 to add support for such archives for applications as well. That's the app CDS feature. And in 13, this has been further on expanded to be able to deal with user-provided class loader hierarchies, so that it's now a dynamic CDS archive feature. And since people here like to play with class loaders, I think that's something that's quite interesting, because it doesn't really require any sort of magic hard setup on your end. All you have to do is run your application with the flag up there, XX archive classes at exit, give it a file it's going to write this representation into, and then your application is done. It will slurp down all the classes in there, right into disk in this more efficient format, so that next time you start it up, you give it this shared archive file path, and it'll start up much quicker. And you can also layer this, and for example, if you have multiple applications running in your environment, sharing the same instance, then you can use this to basically pre-compile in that sense your common libraries and do the same for disparate applications, so that you can that way further reduce your memory usage, for example, in your instance. So beside those big things, there's a whole host of smaller changes that don't necessarily make it to the JEP level. JEPs are basically 2 weeks of work or more, but there's, of course, with every release, thousands of other changes, some of which are more notable. They make their way to the release notes. Others are there in the bug system for you to peruse. And as with every release, we remove some things, such as, in this case, some internal packages. We deprecate some other things. For example, the verify none and no verify options are getting deprecated from the hotspot VM. And we update other things as we go along. Okay, so that's 13 in 10 minutes basically. Okay, 14. 14 is still in development, so there isn't really a final version I can tell you about, a final story I can tell you about it. But what's here today is firstly the schedule, so we know when it's going to come out, March next year. And we know that by mid-December, we'll have a pretty good sense of what's in there. That's when the ramp down starts. And as I said before, ramp down is basically when we know this is it, we're done adding features, we're done fixing all sorts of bugs. From now on, we focus on delivering the release 3 months later. And so far, the JEPs that have been targeted have been, again, across the board. There is a VM feature, there's a class library feature, there's another sort of VM class library feature that's in between. And there are probably going to be more to come in the next few months. The nice thing about this plan is that we release on St. Patrick's Day. And for me personally, I mean, this whole fast release cycle between St. Patrick's Day on one end, Oktoberfest on the other one, that works really well. I mean, that's fine. We can keep doing that. All right, so features. The one thing that's in here has been contributed by Intel, non-volatile mapped ByteBuffers. That's quite a mouthful to basically explain that we're adding a few new modes to file channel APIs to be able to map things into memory. And so there is a new module, JDK NIO map module, that adds a few specific modes that you can use with file channel map method, so that you can basically do things you couldn't do before in specific operating systems. And in this case, that's 64-bit Linux and 64-bit ARM Linux, since they have the corresponding native C library capabilities. In theory, Windows could have the same capability as well, but that's not currently in scope for 14. And then another contributed feature from SAP in this case has been JEP 358, helpful null pointer exceptions. And I mean, just ask yourself, when has a null pointer exception ever not been helpful, right? They're all helpful, but they could be more helpful. And in this case, in this JEP, the idea is to improve the usability by describing, well, what exactly was null to begin with. That sounds useful. And in fact, it is. So if you have various bits and pieces of code where a null could occur, you would then, with 14, get a more descriptive error message, such as, exception in thread so-and-so, null point exception, cannot assign field I because A is null. And in cases that you've been just working on this code and you saw this in your CI system, that may be useful, right? It may save you a trip to the debugger. Similarly, in cases where you have chain method calls or arrays of arrays of arrays, this becomes actually more descriptive and more useful in practice. This is not a compiler feature. This is a VM feature. So the VM will, when a null point exception occurs, go back to the bytecode and do basically a runtime access path analysis, which is thoroughly described in the JEP. I recommend reading that if you care about implementation details, to be able to create the corresponding correct error message for you. There are some cases where this can't really be done, where you say have a null pointer exception occurring on the wire through RMI or something like that, right? So in that case, you would still get a not too helpful null pointer exception. But in those cases people most care about, you would now with 14 get that. And then there's this in-between feature, VM and class libraries. We have, as part of moving to this new release cadence, open source the stuff that was only in Oracle JDK but wasn't in OpenJDK, such as the Java flat recorder. And that's now in our OpenJDK builds and in source code. And flat recorder is basically, as the name says, a technology you can use to get into your JVM while it runs, turn on various recording options, get a sense of what it's doing, record this event data to disk, and then analyze it later through, for example, mission control. And there is support libraries for that. That's all good and nice, but it requires you to really, turn it on, log some stuff, turn it off again. And that's nice when you know there is a problem that you want to look at. But sometimes you just want to monitor things. You want to have some sort of streaming access to these events. And so with 14, we're adding a new package, JDK JFR consumer in the JFR module that lets you actually subscribe to events and get them for continuous consumption of such data. So that you can basically use both. You can do on-demand flat recorder event logging, and you can use streaming access in your own libraries, for example. And there is a whole host of other smaller changes coming in already. So there's, again, deprecations of APIs. There are removals of things. One change I would like to draw your attention to, though, is that somewhere here in the middle, classes are now loaded and linked by class for name. Since I know that people here like to play with class loaders, which is, I think, what the specification said already, but wasn't necessarily always the case. So that may be a good reason to try a JDK 14 early access build in your CI systems. And if we notice any regressions, let us know about it so we can fix them in time. Now, I know that not everybody has time to follow another mailing list. So with OpenJDK, we don't have Instagram, but we do have a Twitter account where we regularly post, whatever new features are being planned for releases, what new candidates there are for releases, if there are any patches of note, any review threads of note that may be interesting for developers to look at. So I'd encourage you to, if you're on Twitter, if you happen to be on Twitter, to not just follow, Eclipse, which is great, but also maybe consider following OpenJDK for such information. And you can see here there is a bunch of candidate JEPs, and so a word of warning about that. JEPs, as I said, is this way we have to describe ideas and features for new releases. They have different states. Candidates, it means it's an idea worthy of consideration for a JDK release. But there is no commitment that it will actually be delivered in the next release or any other one. So it doesn't mean that it's going to be there. So take that with a grain of salt, because the JEP process is relatively complex. And the interesting part of committing things to release happens when it's actually targeted there in the middle and then gets delivered. Until then, things can change. They can go back and forth. Nevertheless, with 14, 3 things are targeted. Today, there is nothing proposed to target, so I thought I'll give you an overview of what there is as candidates. But like I said, this can still change. You can, of course, type the URL if you want. I'll wait. Or you can just go to bugs, OpenJDK, that's our bug tracker, and then when you search, click on JDK as a project, type of issues is JEP, and then search for candidate. It'll give you a list. The thing I recommend looking at is always, has this been updated recently? Because it indicates somebody's actually looking at this more closely, because there is more than 30 different ideas being thrown out here, and not all of them have been touched, in the past couple of months. Another way we develop ideas in OpenJDK is through projects. That's where the bigger ideas get developed, such as Portola. That's a port of OpenJDK to the Alpine Linux operating system, actually to the Musel C library, which is slightly different from the GNU C library in that it's much smaller. And so, when you're running containers, being able to run distribution that's just 5 megabytes on disk instead of being 150 can make a difference. This is a separate project that hasn't been integrated in the mainline yet, so if you care about that, you can check out the Portola project and provide feedback on that. Valhalla is a project in OpenJDK where we're looking at optimizing data layout within the JVM so that when we have an array of simple data types in memory, today it looks like this. Things can be very far apart in memory, linked together to pointers, and it would be nice to get to a world where it looks more like this, so that your types, arrays of simple types, laid out in the most efficient fashion in a single memory block, which would make both memory usage better for those types, as well as performance better, because it's a contiguous area of memory. So that's a quite exciting project that also has various builds published you can look into. Then Panama is a project trying to bridge the gap between your Java code and the system code that's typically written in something like C or C++. Today we have JNI for that. Not everybody loves writing JNI. In fact, I've never met anybody who loves writing JNI code. Neither does the JDK team, I would say, because we're trying to get rid of all this native stuff, as you've seen from the socket reimplementation in 13. And Project Panama is about finding a better way to generate the corresponding assessor code, marshalling code on the VM side through new tools that lets us use native functionality more directly from Java without having to go through this whole C, C++ workaround. Project Loom is a project that tries to look into ways to evolve the concurrency model by providing the VM with fibers, with really lightweight threads and continuations that can be spawned and scheduled within the JVM itself without having to go through the operating system context switches, which means that certain kinds of applications can then run much faster within the VM itself. So that's also quite interesting in terms of where Java could go. And then Project Amber is probably the most interesting in terms of Eclipse itself, which is an IDE for developing Java. Amber is where we work on new language ideas. That's a project that's delivered the var keyword in JDK 10, the switch expressions now in 13, and text blocks. And there is a few other smaller as well as bigger ideas, such as pattern matching, that are being explored within Project Amber. And then last but not least, there is a project in OpenJDK that doesn't really deliver any JDK feature itself. It delivers a better way to develop the JDK. We've used Mercurial for the longest time in OpenJDK. We continue to do so, but it turns out that a lot of developers who've been born in this century prefer Git. And we've been hitting against limits of Mercurial, actually. So in SCADA, we're evaluating the use of Git, and in particular, GitHub as a hosting platform for OpenJDK development. A couple of projects, including SCADA itself, have moved over to GitHub. You can find them in the OpenJDK organization, as well as Loom, the one with fibers I mentioned before, and OpenJFX. And one of the nice things about that is that the contribution onboarding becomes much, much easier because so many more developers are familiar with, say, how the GitHub pull requests work than they are with, all right, I'm going to go and read 20 pages of docs to figure out what's with the batch and the right mail list and whatever. So SCADA, I think, is quite exciting and can be a good way to get more fresh blood into JDK development. and more new things in future releases. So with that, I'll come to the conclusion. 13 is out there, enjoy it. 14 is being worked on. You can get early access builds, try them out, let us know if stuff breaks. We'd be happy to know about that. In particular, if stuff doesn't break, let us know as well. That's even better. And if you're interested in the bigger new features, Valhalla, Panama, there are also builds for that. And there are other tools like JPackage that are being explored as well to make your life in this in this new world more exciting and pleasant. And with that, I'll thank you for your attention and hope you enjoyed the reception.